Good day, grade 8s. I'm Miss Babo, and today's lesson will be about expansion and contraction. When an object gets bigger in size, we say it has expanded or expansion has occurred. And when an object gets smaller in size, we say it has contracted or contraction has occurred. Materials like solids, liquids, and gases will expand in size when heated and contract when cooled. This is due to the particles that are in constant motion, and they can be influenced when heat is applied or when heat energy is removed from the substance. When materials are heated, the movement of the particles will increase and the size of the spaces will increase, which in turn increases the size of the substance. This is because the particles will move faster as they have more kinetic energy, and they will move slightly further away from each other, which will allow for the substances to expand. As you can see in the images provided, when the heat increases or when the temperature increases, the movement and the spaces of the particle increase too. Now, when materials are cooled, the movement of the particles will start to decrease because of less kinetic energy available for the particles, because there is less heat energy applied. So the slower movement will lead to smaller spaces that will occur between the particles, which will then allow for a substance to contract. What is important to remember about the concepts of expansion and contraction, that it is not the amount, the mass, or the size of the particles that change. It is only the spaces that are found between the particles that will either become bigger when expansion occurs or become smaller when contraction occurs. That is the only factor that changes for expansion and contraction. Let's look at a few examples of where we can see contraction and expansion in our daily lives. So, if we take a tin roof for an example, what happens to the roof during the day? When the metal roof panels will receive heat energy from the sun, they tend to expand. This happens when you hear a creaking sound in the roof, and the same will happen at night with the creaking sound, except now because of the colder temperature, those particles of the tin roof will move closer together, which again gives a cracking sound but shows us that a contraction is taking place. Another example where we can see expansion and contraction in our daily lives is with power lines. So with power lines, usually in the middle of the day or in the afternoon, the power lines hang a bit lower than usual due to the heat from the sun that will allow expansion to occur within the metal of the power lines. But at night, contraction will occur there due to the drop in temperature, which will allow for the particles to slow down in movement slightly of the metal to contract and pull the power lines back up to a more straight line. Our last example here is a mercury thermometer. So a mercury thermometer is an older type of thermometer where liquid mercury is used in the actual thermometer because mercury has a very low boiling point. So when these thermometers were used to check your temperature, because of your body temperature, it would cause the particles in the mercury thermometer to heat up, which then will push the mercury higher up within the tube to give us an accurate reading of your temperature. An experiment that we can conduct to show the difference between expansion and contraction is called the ball and ring experiment. So as you can see here, the ball is dipped into cold water and it can slide clearly through the ring. But if that ball is heated up, it shows expansion has occurred, which means it will be unable to fit through the ring. When we cool it down in the water, it means contraction has occurred and it will slide easily through the ring. This shows us that when a substance is heated up, expansion occurs, and when a substance is cooled down, contraction occurs. Remember, we are not changing the size of the particles, the amount of particles, or the mass of the particles. We are simply applying heat energy to allow spaces to occur between the particles. Thank you for coming to my lesson. We will see you next time for chemical reactions.